Hello, friends. This is the AlphaList podcast. I am your host, Toby. The goal of the AlphaList podcast is to empower CTOs with the info and insight they need to make the best decisions for their company. We do this by hosting top thought leaders and picking their brains for insights into technical leadership and tech trends. If you believe in the power of accumulated knowledge to accelerate growth, make sure to subscribe to this podcast. Plus, if you're an experienced CTO, you will love the discussion happening in our Slack space where over 600 CTOs are sharing insights, or visit one of our events. Just go to alphalist.com to apply. Welcome to the AlphaList podcast. I am your host, Toby, and today I have a very special guest. His name is Yonatan Zunger, and Yonatan is distinguished engineer at Twitter, and he has been a distinguished engineer at Google beforehand. And I have to say, he has a very impressive CV because he was one of the folks responsible for introducing GDPR at Google and stuff like that. And I think distinguished engineer is kind of for individual contributors, the highest level you can get to. And then there's way more, and we come to that. Yonatan has 45K followers on Twitter, and his account is protected. So welcome, Yonatan. I tried to follow you on Twitter. I was not able to.
I apologize. I used to be extremely active on social media. I actually got off of it for personal reasons a few years ago. I might come back though. It's definitely an option. And by the way, it's a Yonatan. Actually, you can pronounce it like you do in German.
Okay, Yonatan. Okay, and I thought when I saw that you're not that active on Twitter, that it's maybe related to a very nice presentation you sent over to me after we first spoke. Disinformation tactics or compromising democratic societies with message injection attacks. Is that related or?
No, this was actually completely unrelated. I genuinely love social media and have really deep belief in its ability to do real good for people. But it also has problems. And in my case, I discovered that I had a personally very unhealthy relationship with it, and it was really messing with my life and with my ways of handling things. And so I decided I needed to step back from it for reasons that have absolutely nothing to do with the politics of the world or the nature of social media or anything like that. And I mean, as you can see, I continue to work in social media actually to provide it to other people. I think it's a wonderful, powerful tool when it's used well. And I'm still a deep believer in its potential.
Well, one could also understand it difficultly, if you work for Twitter and have a protected account, that you, in a way, maybe see it as a very dangerous thing. That was my first thought.
No. Actually, the protection, I don't tweet even in protected mode right now. I literally backed away from using social media. But this is 100% a personal matter. It's very much about things that have literally nothing to do with anything that is interesting to the wider world. It's which is kind of odd, right? I mean, you really want to be out there using the product. I feel like when I was I used to be technical lead of social at Google, and now of course I'm working at Twitter, and I find that actually using the product is one of the most important things you can be doing for many aspects of this, right? Understanding your customers, understanding their experience, and so on. Right now, my job is focused more on the back end of making Twitter itself function. So that's not as crucial for what I'm doing day to day. But if I were to be working on the front end of social again, then I would absolutely have to be actively engaging in the product.
Okay, understood. You also have a very popular Medium account, and I think Rachel Podwin recommended talking to you and getting you as a guest because you have written very good articles on Medium. And there, you also have a subtitle, I think either political analysis of authoritarian regimes or interesting facts about science depending on my mood.
It's true. When I was first when I first started writing for a public audience, I was actually doing a lot more science writing. And if you dig through my Medium, you'll find older articles about why are barns painted red traditionally, or the history of the Allied war against the Nazi nuclear program during World War II, which was tremendous fun to write. But as the world changed, I started spending more and more of my time writing about issues that were very practically important. And I think this goes to sort of one of my core professional, in both professional and personal interests, is really the ethics of our profession. I think it's the impact and the significance of the work we do today in computer science is so profound, and we need to be extremely aware of how what we do affects the real lives of real people. And especially in the current world, that means really understanding the intersection of computer science and politics. It means understanding how social media and politics go in, which goes to that talk that I gave at a conference a couple of years ago about how social media can be used to actually compromise democratic societies. But really, I spent a lot of time really writing very seriously about politics, about unfortunately, the shift towards the rising popularity of authoritarianism in the world today. But recently, I took a break from writing at the same time that I took a break from social media, but I've recently come back to it. And right now, I'm really trying to write more specifically for an audience of not really an audience of engineers. It's really an audience of people who are in a world where an engineering mindset might be appropriate. And a lot of these things, even though I often speak in the language of engineering because it's my professional home, these are no less applicable to human resources or to business management, many other things like that. And they're certainly very applicable to adjacent fields like product management, UX, things like that. And so that's where I'm right now really focusing with my writing, trying to really talk about the things that are important to building good systems, because systems are really what holds our world together.
Maybe before we talk deeper about your articles and your thoughts, can you quickly explain how you got into what you're doing? Like, how did you become a geek or nerd? I don't know how you classify yourself.
How did I become a geek or nerd? Become implies that I was something else before this, which I don't think is exactly right. I've always been this. So I actually started my career as a theoretical physicist. And I think I was always very interested in sort of like, well, why does this work? Well, why does that work? Why does that work? And so I kept following that path all the way down to becoming a string theorist. And then discovered that academic science is not something that actually brings me great joy. It's culturally, it's a very interesting field to be in. But I wish to say I really got sick of it really fast. But through a very random sequence of events, I ended up talking to some people at Google. And this led to my coming back to my office one day. I'd had a meeting with Google, and someone had accidentally brought up this super secret project to index all the world's books. And I remember driving back to my office and thinking, that is more interesting than anything I've worked on in the last several years. So I got back to my office, I sent them an application, and somehow, I don't know how to this day, I got the job. At Google, I started out working on search. I actually worked on the core ranking. I was one of 3 people who was actually in on the full system of how ranking worked, and we weren't allowed to be on the same airplane as a result. Then started just taking on more and more interesting projects. So I ended up running the high capacity search team, and I ended up running another team on planet scale storage. And then there was a moment when Google started to get very into social, so I got into that one. And in the course of what happened there was that Google needed a technical lead for all of its social work. So Google Plus, News, Blogger, Photos, Hangouts, all sorts of things like that. But it turned out the most interesting, the most difficult problems that really needed attention there were actually around things like security, privacy, and abuse. This is when the GDPR was in its drafting phase, for example. And so I got very deeply involved in that space and really fell in love with that field, which I think is how I ended up also writing about politics quite so much, because the overlap was plain to see even then. And I've worked on many other things since then. But I think I fell into geekdom just by loving building systems. I think ultimately I love looking at problems and analyzing them and thinking about them and taking them apart and figuring out maybe there's a way we can fix this. Maybe there's a way we can do something better.
And privacy engineering, also as a topic, which, kind of is trending, unfortunately, or fortunately, I don't know.
I think this has become, I think, possibly my greatest love. And I mean here privacy in the broadest sense, not just compliance or something, but really how do
Yeah.
you? It's really the study of the failure modes of systems that involve humans in an intimate fashion. And I think for this one, though, if we want to have a good privacy conversation, we should really have Leah Kistner on board this meeting. They are a longtime colleague and friend of mine. We work together on social. They've headed privacy at Google, privacy engineering. They are sort of the founder of the modern field. And they know so much more about this than I do. I mean, I have worked on this field a lot, but they are in a completely different league.
Okay. And responsible for CISO now at Twitter, right?
Yes. In fact, they currently head both security and privacy type matters. CISO as well as, privacy gets split up between the engineers and the lawyers in an interesting fashion, but they work very closely with the legal head of privacy as well, and are trying to protect people on the internet, basically.
Great. When we first spoke, you also brought examples about how dangerous actually AI can be, and how harmful a classifier, and that this also motivates you to stick to that topic.
Yes.
And I found it very fascinating. You brought an example from a conference where, I think someone from the police was actually attending.
Oh no, this was not someone from the police. This was a case of someone in academia who had been working with the police.
With the police.
Built a classifier that identified which people are likely to be members of gangs and which crimes are likely to be gang related. And the problem in this one, and I should say, it's not that I believe that AI is dangerous. It's AI happened to be the tool, but this was a dangerous use of computer science. But the idea is that you're attempting to detect what's gang related, but this system is going to have false positives and it's going to have false negatives. But the people who had built it really, it was very clear that no careful thought had been taken about what is the consequence of a false positive for a person's life. Because if someone gets described as a potential gang member to a police system, the police are going to start to be interrogating them all the time. They're going to be hunting them down. The criminal penalties for anything they do will become higher because of that. This is a system with real, potentially very serious consequences also, because I have to say that a lot of police departments are, they tend to view the public as enemies almost, rather than as the people they're trying to protect. And if you start to equip organizations like that with a tool that tells them, oh, look, you should attack this person, you should go after that person, you should go after that person, they're not going to be culturally looking for, hey, is this a false positive? Should I actually be going after this person?
Yeah, obviously.
Default to doing it.
Yeah.
And this was a case of the people who were working on it were quite literally just not paying attention to this when they were questioned about it at the conference. Rather infamously, the presenter responded that he was just a simple engineer. He didn't know about these things.
That's
what we must never say in our profession. There is no such thing as a simple engineer who is not responsible for the ethical dimensions of their work or the consequences of what they build.
Yeah, obviously. And I think you've seen more examples maybe at companies like Google where I mean, there's so much responsibility on Google's shoulders as well. So I can only guess that there are more examples.
Absolutely. The slightest mistakes in a system can have incredibly serious effects for a person's life, right? I mean, I've seen cases where an unclear user interface caused someone can cause someone to accidentally out themselves. And nowadays, to be queer, to be trans, to be something like that can be actually a very dangerous thing. I mean, when I grew up, it was still very routine in the United States for people to have their children taken away, to lose their jobs and be banned from their careers simply if it was discovered that they were gay. This has gotten better in the past couple of years, but I can also see it getting quite a bit worse. And in a lot of the country, it still isn't that good. But I've seen cases where, a simple lack of clarity in a UI, and no one did anything wrong in the official sense, right? There was no design mistake. There was nothing that I would describe as a legal risk or a legal violation or something, but an accident happened where someone didn't know which identity they were communicating as. They communicated as the wrong identity and outed themselves to their boss. In this particular case, thank all of the gods, nothing bad happened. Like they weren't physically harmed or something like that. But this sort of thing, I mean, this is what keeps me up nights, right? It's because even if you do everything 99.9% right, that last 0.1% can still have a really profound impact. And the simple scale of the tools really affects that too, right? If you have a tool that billions of people use, that means that rare events happen. A good friend and colleague of mine, Andreas Skau, he had a great way of putting it. He said, if something happens to 1 in a million people once a year, here at Google, we call that 6 times a day. and he's right. These extremely rare events for individual people become routine things you have to actually think about how are you going to deal with. And these corner cases, they're very serious. And I think that the real discipline of, when we talk about privacy engineering in the broad sense of the word, it's really about, it includes these things every bit as much as, tracking how data is used. Honestly, I think that these things are often the most important aspects, because it's really about, and now to quote Leah Kistner here, it's about ensuring respect. It's ensuring that our systems provide respect for the people who use them and who are affected by them, and respect their wishes and their needs and their daily lives.
Great. So, but maybe let's step back, or let's step over to software architecture and the topics you just mentioned. You cover with your articles these days. Like, first of all, what is a distinguished engineer?
So, I think we are gradually heading towards a uniform set of job titles for engineers of job levels. It's a bit slow, but I think we're starting to get a convergence on the meaning. The way I tend to think of this nowadays is you can sort of separate engineering IC grades into sort of 3 major bands. The junior grades, which maybe counterintuitively go up to senior engineer, these are jobs that are about executing a task. Right? So you start from the most junior engineer who needs like very close supervision, up to a senior engineer, someone that you give them a task and they can execute on their own. They can supervise other people. They're basically fully independent professional engineers. That's sort of the first band. The second band, the mid grades, the levels we normally call staff and senior staff, these are about solving problems rather than executing tasks. You're given a concrete problem and you need to work on it. So, for example, I got promoted to both staff and to senior staff for working on high-capacity search at Google, where basically we had the problem of we need to add several zeros to how many documents our search engine can support. And the current theory of search engines does not actually include any approachable work for doing that. So we'd better do it a different way. And I think the sort of the key difference between staff and senior staff is the running of what I call dependent versus independent teams. So an independent team is one that has customers of its own, either internal or external, whereas a dependent team is part of a larger independent team. So a staff engineer is typically leading a dependent team where they're part of a larger team, and that team says, hey, we've identified this problem, we need to solve it. Please figure out what needs to be done, solve that problem, and then go execute on it, make it happen. And a senior staff engineer is at the point of, here's a problem. We know there are customers, there are people inside or outside the company that care about it. Make it go away. Then you get the senior bands, and that's now the principal and the distinguished engineers. So going back to your original question, and the senior bands, instead of getting a problem or a task, you get an area. So principal engineer is typically handed some area of the company, storage or whatever. I mean, of course, the scale of it depends on the company in particular. Actually, principal, distinguished, and at some companies there's also a fellow band. It sort of varies, the exact titles. We haven't stabilized quite as much yet. But roughly at each of these levels, you're getting an area of the company or an area of problems, and you're told, hey, there are probably problems in here somewhere. And so typically at whatever is the highest level within a particular company, which I think is distinguished engineer at most companies nowadays, except at some of the larger ones, the role of the highest level engineer is basically, you don't even have a specific area. My job description at Twitter is literally, you should go talk to people, figure out what's broken, and go fix it. That's what you do.
And go fix it through not like necessarily fixing it yourself. I mean, maybe you
No.
do still code every once in a while,
I-
but through like accessing the full bandwidth of teams available, or
Absolutely. It's the work becomes more and more rapidly interdisciplinary as you go up the chain. I mean, most of what you're doing at the level of a principal or distinguished engineer is you're assembling teams, and you might be leading them. You might be giving them direction. I found that one of the biggest parts of my day-to-day work is really it's helping with actually more of the sort of the product management side in a lot of ways of a team, figuring out what needs to be done and why. But on the other hand, sometimes I'm also writing code. For one of the teams I have right now, I happen to be the only engineer who's working on a particular set of problems. So if we need code for something, I'm the one who's going to be writing it, which is fun. I have to admit that I still do really love writing code when I have a chance.
And is it complicated to convince people that like the stuff needs to be done that you come up with, or like how is your? I mean, it's all lateral leadership in a way, right?
Yes.
I assume.
Absolutely, and it's hard. But that is literally the job, right? The job is to figure out what needs to be fixed, convince people it needs to be fixed, build the institutional momentum behind fixing it, assemble whatever teams need to be assembled, whatever resources need to be pulled together, execute, and actually do these things, right? So it's really it's end-to-end leadership, and I guess the way I tend to think about this when I'm thinking about sort of end-to-end leadership of a project. There are 4 kinds of skill in any profession, right? So there's the core technical skill of that profession. That can be writing code or litigation or whatever it is. It varies tremendously. There's product management, which is figuring out what needs to be done and why, crafting a narrative, getting everybody on board with it, keeping everyone on board with it, maintaining that narrative. There's project management, which is turning strategy into tactics, right? It's making sure that the trains are running, making sure that nothing is being forgotten or ignored. It's being able to understand what is even going on right now. It's making order out of chaos. And finally, there's people management, which is building the teams that actually do this and building up the people, finding the people you need, growing them as people and growing their careers, helping them, structuring them. For a project to succeed, you need all 4 types of leadership. And of course, no one person can do all 4 of these well, right? I think everyone tends to have one that they are very good, 1 or 2 that they are very good at and love, 1 or 2 that they can do if they absolutely need to, but would rather not, and 1 or 2 that they just hate and would really rather not. But what you do need in order to make a project succeed is to get all 4 of them. And so a lot of the role of any senior leader, whether they're, and I think that's one of the important points about a distinguished engineer, is that the boundary between an individual contributor and a people manager and so on gets incredibly fuzzy at this point. The job of a senior leader is to identify problems that need to be solved and make sure they're getting solved, to make sure that all of those things are present. And generally, I think in practice, especially for an individual contributor, someone who's formally on the books, an individual contributor, one of the most important aspects of that is exactly the product aspect you mentioned. It's convincing people. It's figuring out a way to clearly and precisely articulate what is the problem and why is it a problem? Why does this need to be solved? And how is it going to be solved? Right? And how, like, what is the actual thing that is going to turn this from an intractable mess into something realistic? That's basically the job right there.
And are you good at convincing?
I hope so. This is, obviously a subject very dear to my heart. I think that actually, in fact, a lot of the stuff I'm writing right now is me trying to distill my best understandings of how to convince people how to do these things into, nice little chunks that I can hopefully teach people. Because another big chunk of my work, a lot of the more people management side of my work, is teaching people. It's really, it's bringing up the next generation of distinguished engineers and so on.
And that brings me to your article, The Layers of the System, which I found very interesting, or a very interesting approach, where you basically came up with like a concept of how systems are built and how problems are solved at the end of the different layers of the system. Can you explain it a bit
Yeah,
deeper?
absolutely. So this is not a general theory of problem solving. This one is a specific tool that I have found to be extremely useful in understanding systems. The idea is that every system has three layers, which we call W, X, and Z, or W, X, and Z, depending on which country you're in. And so the Z layer is the highest layer of the system. This is the sort of the actual product that you're building. And what characterizes the Z layer of a system and the teams that build it is that they are iterating very quickly, trying to find a product market fit. And they are trying to try new ideas all the time. In a typical company, you're going to have hundreds, even thousands of Z layer projects going on at any given time. And each one of them is trying to figure out, is this a good idea or not? They want to prototype quickly, they want to execute quickly, see if it works, throw it out. That's an important thing, is about in a healthy state, 90% of your Z layer projects should get thrown out. If they aren't, then you're probably not trying enough good ideas to be getting somewhere. Next layer down is the X layer. And the X layer is the infrastructure that speaks the same language as the Z layer. So, it might speak about users and feeds if you're building a social network, or customers, whatever is natural to your thing. And the job of the X layer is to make it as easy as possible for the Z level teams to experiment rapidly. So their measure of success is that Z level teams can try things out without having to think about anything that isn't directly related to their problem, because Z level teams like to be very narrow. They understand this product issue really, really, really well, and they do not know anything about the adjacent issues, or they're not infrastructure engineers, and they don't want to be. And then the next layer down is the W layer, and that's infrastructure that speaks a different language. So it might speak integers and cores and bytes instead of users and feeds or something like that. And W layer infrastructure, obviously, its job is to make the X layer possible and performant. The W layer is also the place where you get the buy versus build dichotomy, right? That's where you have the option to buy something, whereas at the X layer you can't buy an X layer off the rack, because the whole point of an X layer is that it speaks the same language as your specific product. So the X layer is inherently something that you're building. At the W layer, you're making choices. But even, of course, if you're buying, you need to be building a shim. You should never be exposing a bare third-party API to the rest of your company, because that locks you into that third-party thing and into all of its idiosyncrasies, and means you could never change anything or instrument anything. So there's always a great deal of engineering work happening at the W layer. And then your fourth category, because obviously a three-layer system needs four categories, is your horizontal functions. And these are things like security, privacy, SRE, legal. These are the teams that aren't thinking about any particular product, but instead are looking at the broad horizontal picture of the company as a whole. They are typically stewards of some resource, like the company's security or its reputation or something like that. And their job is to make sure that everybody in all of the other teams is not going to set the company on fire by accident, basically. And so then the reason this partitioning is useful is because you start to see real patterns in the way these teams work, and both in the ways that they work together when things are going well, and the ways in which they work together when things are not going well, because you start to see some very characteristic dysfunctions that can actually then be addressed in repeatable ways.
And if you look at like your daily work, do companies typically spend too much resources in one of those layers? Is that possible to say, or is it like that maybe like the older companies tend to build too much in the W layer, so build too much infrastructure, or like is there like some pattern that we often see out there?
I think the main pattern is that there are often imbalances and bad relationships, and they are different in each case. Each company has its own dysfunction. So I'll give you an example of, I think, one thing that's very common in the Silicon Valley world, because it happens when you have a startup, right? So let's say I'm creating a brand new company. Typically, startups tend to focus very heavily on the Z layer to begin with, because they are just a product and nothing else. They're going to try to buy a W layer, build a Z layer directly on top of the W layer with no thought towards like this long term of this. Just, we need to build a Z layer, get it out, try out the product. And hopefully they get some idea that works. Hey, great, you've got the successful product, everything is going great. Now you build a second feature, and then a third feature, and a fourth feature. They're each sort of being built as quasi-growths on top of the first feature that you built. And what happens after you do this for a year or two is that you've suddenly got one of your first classic failure mode, the one I call XZ mixing, where basically there is no clear X layer at all. You just have a bunch of Z layers overlapping with each other. And what goes wrong here is that because they overlap like this, you can't change one Z layer without potentially breaking the other Z layers. So suddenly every Z layer team needs to be thinking nonstop when they make a change of, okay, how do I change this without knocking over everything else? And they have to collaborate with all the other Z layer teams, and they have to understand all of the history and the intricacy of the system to make any progress. And development velocity comes to a grinding halt. And the way you get out of that particular situation is you actually have to create an X layer, something that I think many startups basically forget to do or say, oh, we don't need to do that. That's a future problem. That like if we make it for 3 years, we can think about building an X layer. And I think what that's really tied to is the fact that Z layer teams naturally work at the time interval of 3 to 6 months, whereas infrastructural teams naturally work at both X and W tend to naturally work at the time scale of a couple of years. And so if you have a bunch of Z layer people starting up your company, they're going to say, well, oh, infrastructure is a long-term project, or we can just buy infrastructure. Because there's an infinite number of SaaS vendors out there who are telling you that their product will solve all of these problems for you. What they don't tell you is their product is a W layer product. What they are selling you is the tool that you can use to solve your problems. It is not a shrink wrap solution to your problems. Companies misunderstand this. They treat W as though it's X. They build this overlapping mass of Z. They end up in just a mess. And the way out of this is you have to create an X layer. So what you do is you actually have to separate out X layer, actually organizationally. It's very useful to separate the X layer out into a separate part of your organization. Treat your X layer like a product team, right? This is not some abstract bad thing. It's actually at the heart of your company. They're a product team. Their customers are the Z layer teams. Understand, what do the Z layer teams need? What language do they need? What APIs make it possible for them to build? And have them really be focusing on building a product whose chief feature is, in a way, isolation. It's to basically let Z layer teams muck about and play with all of the ideas they can and limit their ability to do damage to anything else. Love your customers, but don't trust them to do the right thing. They will screw things up all the time. And
reminds me of like you can also have that like fully alone without having a company, just using like a no-code tool, like Airtable, for example. I'm a huge fan of Airtable. At a certain point, you just mess things up, right?
Well, again, I said I'm using the language of engineering here, but this is much more general. You don't need a company to have this problem. You don't need to be doing engineering to have this problem. And you should recognize that your Z layer is somebody else's W layer. I mean, social media is the infrastructure for a lot of people's daily lives. So that's you have to understand that you're actually providing an infrastructure for other people to do things, and what they're doing on top of your system is very different from what you're doing.
So, like in which of those layers are you seeing at Twitter maybe the biggest problems? Is that like the middle layer?
Well, I think it's different at every company, and it's different from time to time at every company. For example, I remember, so when I was at Google, when I took on leading social, we discovered that we definitely had some big XZ mixing problems, even in a large, very established company, because what had happened is we had grabbed a bunch of like existing systems, very quickly tried to build a social system on top of them. We recreated this classic startup problem even inside a large company, and so we needed to build an X layer. Twitter actually has existing WX and Z layer teams, and in fact, when I joined, it had already been factored this way. And I've spent the majority of my time at Twitter working with the W and the X layer teams, because I think that's where there happened to be things that really needed my attention, where I could most usefully assist. Whereas the Z layer teams were iterating as fast as they could under the circumstances, but we needed to make the circumstances better for them. But I actually also spend a great deal of my time with horizontal functions, again, going back to security and privacy, because, real professional systems are all about building systems that will fail well. And if you are building something at the scale of Twitter with, I think it's the 5th highest traffic website in the world, it's used by hundreds of millions of people for their friendships, for their jobs, for all of this stuff, things can go really wrong. I mean, the failure modes of Twitter apparently include nuclear war, something I did not expect to have on the list of social media failure modes a couple of years ago. But this is a forum where international politics happens. Surprise.
Yeah, obviously, especially Twitter is kind of the network that is often chosen by politicians. And yeah, I mean, we all know that Donald Trump was very active there, and there's like lots of dangerous stuff happening as well, right? And steering that.
and you should not fall into this English language focus too easily. Donald Trump was there, but a lot of other people are there too in a lot of other languages. Doing very important things.
Obviously, I know. I mean, it's just like the easiest example that everyone thinks of, right?
Yes.
Is it like does it sometimes scare you to be responsible for this as well? Like,
oh God, yes. if your work doesn't terrify you, you don't understand what you're doing. Let me rephrase that. If you're in CS and your work doesn't terrify you, either you're working on something pointless or you don't understand what you're doing. But you know,
go ahead.
Every branch of engineering, I think, goes through this at some point. I think civil engineering was sort of one of the first to go through it. They really went through a period in the late 19th, early 20th century of understanding how serious it can be if buildings are built wrong, right? I mean, we had like a series of building failures, of bridge failures, of things like that really deeply shaped the profession and like really caused. I mean, nowadays, if I have friends who are civil engineers, like you see it, they are safety engineers who also happen to be building a road almost more than anything else. And other fields, I think physics really got it with the bomb. Chemistry got it with both chemical weapons and dynamite. CS hasn't had that yet, but the things we're building, I mean, you're not building to take a civil engineering analogy, you're not building a gazebo in your backyard. You're building a skyscraper in the middle of a business district that millions of people are going to be walking in and out of. You had better be frightened of what can go wrong because it's really serious.
I mean, hopefully it won't be there won't be that one key moment when everything changes, right? It's just like what I
I mean, I think honestly, CS should have had this moment back during the Holocaust, right? I mean, it was really these early tabulation systems that were being used to drive the cataloging and extermination of people. Had people been paying proper, but CS wasn't really a field then, right? It didn't have a discipline and a language, and so I think people haven't necessarily absorbed that one as much. And I'm very, very frightened about what could happen next if people continue to be very careless and slipshod about these matters.
Well, Twitter could be acquired by Elon Musk, for example.
Yeah, obviously I can't speak about the acquisition or the lawsuit or anything.
I can imagine.
I think Twitter is definitely in a place where doing its job well is really important for the world. I think a Twitter that does its job well, that really creates a forum where people can meet each other, speak, where there can be a public conversation in particular, which I think is Twitter's greatest strength as a social network, as well as these more private, more intimate conversations, which is really sort of the backbone of forming social bonds. If Twitter does that well, the world is much, much better off. If Twitter does that poorly, bad things are going to happen. So, that's a case of the work matters.
Absolutely. And also, if you compare it to other social networks, I see Twitter like way more as a journalistic platform, which is to be taken seriously. And that's a compliment from my perspective. I mean, if you look at Facebook and the others, there's so much more power in it these days, at least.
Absolutely. I think the importance of journalism cannot be overstated. It's such an important thing in our world, and I think that the changes in journalism that have happened as a result of the internet, I think most of them, with a couple of very marked exceptions, I think have been incredibly positive. The rise of citizen journalism, the number of people really doing journalistic work is a wonderful, wonderful thing. I think the decline of beat journalism is, I think, a much deeper problem, but that's a whole separate conversation.
Yeah, maybe we step back to the future of computer science then. Like, what do you think the field will look like in, let's say, 50 years? I know that it's a bit far down the road, but what do you think needs to change?
I think the biggest thing that needs to change, and I know this is going to be very hard for a lot of people in the field to hear, and I think it will make a lot of people say, no, you can't do this. It's a shift towards professionalization, by which I don't necessarily mean gatekeeping, but to some extent there has to be more care. Going back to that gazebo analogy, if you want to build a gazebo in your backyard, I mean, technically there are various regulations you actually still have to follow, but ultimately I don't care too much what you build in your backyard. But if you're building a building that people are going to be using, there's so much cross-checking, so much process around making sure that building is actually a properly built building. Right? You have to have a professional engineer who is signing off on the designs. You have to have multiple layers of cross-checking. There's an entire system for everyone from the architect to the guy who is actually putting up the walls to raise issues when they see them. There's so much systematization about this. I think that if you look at CS 50 years from now, I think we are going to need to be much more like that, where we have an understanding of the difference between a small hobby project, where obviously you don't need or want heavy process, and a serious professional thing, a system that's going to affect a couple 100 million or a couple of billion people, where you're going to have a very different approach. I think that ultimately that's going to require changes in both the way the profession works internally. It's going to require changes in the interface between the profession and the legal world. If things go well, I think that we're going to end up in a situation that looks a lot more like the situation of civil engineering. I really see them as a model for where we should be going. And of course, a lot of people are going to say this is a problem, right? Because the whole great thing about computer science is that everyone can try ideas. There's no gatekeeping. There's no boundaries. This is both good and bad, right? You want people to be trying out ideas. You don't want people to be trying out ideas on a couple of billion people and then finding out that it's a bad idea.
Yeah, question would be if Jack Dorsey would have ever come up with Twitter if those boundaries were there, right?
And I think the answer is yes, actually. I think it process does not eliminate innovation. I think there's a lot of fear of that, I think, especially in Silicon Valley with its startup culture. But, Formula One race crews have process. Like a pit crew, they have an exact, very designed process, and it's what makes them fast. If you are, you want to be in a world where I have some crazy idea, just build it, try it out. This is not the point where you want to have heavy process. As your crazy idea is starting to affect more people, right? If you are moving towards large-scale releases, large numbers of people being directly affected, larger impacts, that's the point where more, building codes essentially need to be kicking in, where you start to actually say, no, you actually need a certified professional who is capable of doing this thing to sign off on this. And of course, you're going to have to balance this very carefully, because what you don't want is this certification to either become a business type of gatekeeping, where there's this small guild that controls all of the things and they charge exorbitant rates or something, or even more so a social type of isolation, where you can only become a certified person and get access to a certified person if you're this white dude with access to all of the connections of an Ivy League education or something like that. You don't want either of those things, and we have to put really profound, serious work into making sure that doesn't happen, because I think that's an obvious failure mode to watch out for.
What are your thoughts then on autonomous teams and full autonomy in companies these days? Is still a trend, and there are companies that have like tens of languages, hundreds of languages for programming being used.
Yeah.
Should it be like this? Or
no, I think that's actually a terrible idea, and for even much simpler reasons. If you have, there's this idea of give teams complete autonomy, and you end up with a train wreck, because then the moment you get to the first thing where, several reasons. One thing is the moment you have things that have to happen across the company, and you have these things like security and site reliability, you can't do it in a world like that. If you have dozens of languages and each system works totally differently, how do you make a change to ensure that every system gets secured against one thing? You can't. It just makes a lot of the actual practical work of anything bigger than a hobby project completely impractical. And of course, you also get a very straight up business problem, which is if an engineer or a product manager or whatever wants to move from one team to another, it's as big a change as them moving from one company to another. They have to learn everything from scratch. This means that you get no flexibility inside your company, no ability to move back and forth between projects. You get less cooperation between projects because they're working on such different languages that they might as well be multiple companies. You're trying to run your startup like a conglomerate, and that doesn't work. I've never seen that turn out happily.
What about Netflix?
So I don't know the internals of Netflix all that well. I mean, I have some friends there, but Netflix has a lot of coherent stuff across the company. I mean, actually, so one of my friends works in performance there, and he's just been instrumenting like their entire world basically so that they can understand performance better.
Yeah.
But he's been able to do that horizontally because there is autonomy on many things, but not on everything. I think that's the important thing, right? You want an X layer. You want to have a coherent system of infrastructure that everyone across the company is sharing, and then you want people to radically innovate on top of that. But you don't want them to radically innovate on just completely different bases across the board.
I just interviewed someone from Netflix, and there's this what she called the paved road, essentially like a highly recommended stack that you use to be in line with the others, and that you can always like derive from that because like everyone is smart in the company. But still, it sounded as if you could also get fired if it doesn't work out. So,
I'm a very big believer in well-lit paths, right? You should make it easy to do it the right way, make it possible to do it other ways. But I think that the important thing is you need to have a justification for moving off the well-lit path.
Yeah.
I think so. In fact, going back to the problem of XZ mixing, I think one of the really common problems I see is this. You end up in a situation where you have all these Z layers piled up together and development velocity slows to a crawl. And the Z layer engineers say, well, I can't build on our infrastructure. Our infrastructure is terrible. And it's like, yeah, you didn't invest in your infrastructure, you get terrible infrastructure, right? And so suddenly the Z level team say, well, if I'm going to make any progress, I need to be able to pick my own infrastructure. And so that I'm going to just buy this like third-party cloud infrastructure. Remember, Z level teams aren't infrastructure experts. They don't necessarily know exactly what they're getting. They just know, I can iterate really, really quickly if I use this one thing. In the short term, they can iterate really, really quickly. In the long term, they've just added even more burden to the infrastructure teams to support an entirely novel system, and they've actually slowed development velocity down even further. And even worse, they've created holes in security, privacy, things like that, because you don't have that uniformity that lets you actually protect these systems in a systematic fashion. So I think that the real approach you need to have well-lit paths. You need to have these easy to do right things. You need to have the ability to deviate from those things. But when you deviate, first of all, you need to have a damn good reason to deviate. And second, when you deviate, there are now responsibilities you take on. Right? The X layer infrastructure, a lot of its point is to take care of a lot of the horizontal functions for you. It has like a lot of security stuff built in, a lot of privacy stuff built in, a lot of reliability stuff built in. If you're not using that stuff, you are suddenly responsible for a shockingly large list of problems. And not only a shockingly large list, but a shockingly large and ever-changing list. Right? I've had C-level teams tell me, just give me the list of security requirements and I'll be responsible for taking care of them. And I have to explain to them, okay, even if I give you this list right now, that list is going to change. And when that list changes, that is now your priority zero thing to deal with. It is more important than the development of your own product. And Z-level teams generally don't actually, like they might claim to like that, but they hate that more than anything else, right? The idea that something has a higher priority than working on their actual core function is antithetical to the whole idea of the team. And basically telling them, hi, I'm going to shut down all of your development and like cut off any ability of you to launch anything until you have fixed this thing is the most draconian penalty you can inflict on one of these teams. And everyone is miserable. And the solution to this is that is what your X layer team is for. Invest in X layers, build them, make sure they're there. Yes, I know infrastructure takes longer to build and that they're talking about a plan that's going to take 2 years to execute, which feels like infinity to you. I don't care. You need that because otherwise you yourself are going to be doing infrastructure for the rest of your life. And that is not what you want to be doing with your time. And that's not what the company wants you to be doing with your time. We want you to be experimenting with crazy features.
Yeah, but there has to be a way to production, essentially, right? That doesn't work out without infrastructure.
Yes, and a way to production does not mean a way to launch. It means a way to maintain the thing.
Yeah, and maintain it for a few years. And typically, when you discuss it that way, then many of the Z-layer teams are smart enough to actually understand this, right? And like if you really talk them through, like get a feeling for how complex it might be if they now introduce Airtable to, as an example, to host all the tweets from now
on. I think this is really the difference between good and bad Z-level engineers. A really good Z-layer engineer, they understand that they are iterating quickly to build something that lasts, to build something that goes out into the future. I mean, one of the real challenges for a Z-layer team is, because they're iterating on these 3 to 6 month intervals, they're trying out new features and so on. The big picture of the product isn't necessarily always being stewarded. And I mean, that's, I think, another very common sort of problem, just a lack of across the board stewardship at the Z-layer and a lack of thinking about the long-term health of the Z-layer teams. But really, I mean, good Z-layer leaders, that is really something that they drive and push, and they make sure that you're not just building good product features, you're building a good product, right? Because users don't use features, users use the whole thing. And maybe they're in fact using not just your product, but a bunch of other products in an integrated environment. And what matters to your customers, to the people at the end of the day, is that integrated experience a good experience? And so often I think some of the best driving at the Z-layer is actually really coming from UX designers, right? People who are really thinking about UX designers and product people with a strong UX bent and things like that, who are really thinking about what is the end-to-end experience that a user gets as they go through the entire product.
Yeah. Or the different products that a company is offering, right?
Yes.
Taking like a company like yours or like LinkedIn or so, there are like so many companies where each of the features could be a company itself, right?
Absolutely. But I think you really need to think about, it's always healthy to think about your product as what do we offer? What is the product? If you have multiple products, you're really running a conglomerate, which is a totally legitimate thing. But then each business unit needs to be thinking, what is the product we offer? Right. And Twitter, it is a social network, even though there's like a bunch of little features in it, right? But ultimately, it's the integrated Twitter experience that we're offering. It's not, the ability to stick an image in a tweet.
Yeah, so it's an interesting area where you could talk about for hours. What do you think are many companies doing wrong these days? Is it that they like just buy instead of building? It has been a recent trend.
I think if you ask me what companies are doing wrong, it actually goes, I think, right back in this WXZ article. I actually had sort of this list of failure modes, and each one of them is pretty much what I've seen wrong at different places. So XZ mixing we've talked about. Another kind of problem is ZZ mixing. That's the case where you have Z-level teams that need to coordinate with each other all the time, which is often actually, it's very closely related to the XZ mixing problem. The WZ mixing problem is actually close to this buy versus build mistake, right? That's something that often happens if you buy and try to you confuse W and X, essentially. You try to build your Z system directly on top of the W system. And what happens then is, first of all, your Z-level engineers need to suddenly start to understand these really deep in the stack details. And also you're completely anchored to the idiosyncrasies, like the idiosyncrasies of your W layer system start shaping your product behavior. And that's not a good sign because W layer systems are being optimized for something very, very different than whatever you're building. And you can't change things, you can't instrument things, you can't measure what's going on and so on. And what's really important there is that you're never exposing a bare W. You always have that shim. You have that understanding of what exactly am I buying and what do I need and what are the differences, and you are thinking about that middle layer between the two. And the fourth problem, which I think is honestly one of the most widespread, is sort of this horizontal disconnect where the horizontal teams, the security, the SRE, the privacy, and so on, aren't being properly involved in the design and launch process of other teams.
because they complicate things.
Yeah, and this is a perverse incentives problem often, because let's say you're the leader of an X team or a Z team or a W team or something. You are a product team, right? You have a product. You are doing product management. You feel like you are being rewarded for delivering things. What you really need to be rewarded for is for delivering success in the long term. But there's too much emphasis on the value of the launch rather than of what happens after the launch. And so you get a team that's like, well, we just need to get this out the door. We have market pressures. We have this pressure. We have that pressure. All they care about is the speed to first launch. But if you get really fast to a first launch that goes poorly, that is much worse than never having launched at all. I just have 2 words for anyone who wants to launch too quickly: Google buzz. I don't know if anybody remembers this thing, but it was one of Google's earlier attempts at a social network. And it's like this really good team worked on this product for so long. I mean, so much effort went into this thing. And there was one crucial privacy mistake in its design. And so it got launched. The privacy mistake became evident. This turned into a massive issue, and like a legal issue and a PR issue and so on. The product got unlaunched. The product sank without a trace, and years of people's hard work vanished because of one tiny little mistake. Right? I mean, that's obviously that's like one of the worst cases. But building systems, I mean, I think an even more common case is someone builds a system that it almost works, except you need a bunch of people behind the scenes to be holding it up and like supporting it nonstop to keep it from falling apart. Right? This is a case where you have a lack of reliability work, a lack of security work, or whatever. And in a really pathological case, you have like the Z-layer team saying, "Oh, well, the infrastructure teams will take care of that. We don't need to worry about it."
I can imagine
no, we can't. That goes poorly. Please don't ever do that.
I can imagine that Twitter at a certain point, maybe before your time, was a bit like that. Partly,
many companies are like that. This is something I've seen over and over across the industry, and I think that this goes to that 50 years question you asked too, right? We really need to think about the processes by which we integrate these horizontal understandings. I mean, not just the horizontal teams, but the understanding at the level of individual engineers, right? Like I need an engineer, especially someone who's leading a team, and not just an engineer, but a product manager and so on. They need to understand site reliability. They need to understand security. They need to understand privacy and abuse and all of these things, because basically, I mean, this is like one of the fundamental dichotomies of engineering. Right? There's product engineering and safety engineering. Product engineering is about how things will work. Safety engineering is about how things fail. You need both. You cannot have one without the other.
Thanks a lot. Like, great insights. Also, like your first hint that like a lot of companies seem to be like too focusing on output, right? Like having this launch date, getting that through the door, and then like a lot of companies also don't care. Like if it's like just about features, they don't care about the feature afterwards whenever they got it through the door and it's not successful. And that's like I see like a lot of companies are not successfully doing like monitoring or focusing on outcome actually.
Yes. Yes. And I mean, that's terrible from a business perspective, right? If the whole value you're getting from a feature is the PR boost from talking about the feature launch and not the actual feature itself, this is not a sustainable business.
So thanks a lot for your insights. And I have one of my closing questions. Typically, did you recently like discover a great tool that you recommend to every one of your friends that you go crazy about, that makes you way more productive or like way better in your job? Anything particularly?
I think given the nature of my work recently, the best tools that I've been discovering haven't been software you can buy. They've been having a process that actually makes sense, which is a tool you kind of have to build yourself right now. But honestly, if I were to recommend one simple tool to people, it's a checklist. Have a checklist of things that you need to make sure you think about. Right? There's a checklist of things to do, and there's a checklist of questions to ask. They're two different kinds of things. But make sure you have that, like an actual written checklist of things you need to make sure you think about before you launch something or before you do something. That's a great way to make sure you don't completely screw up. It's a very old-fashioned tool, but it's incredibly effective.
The very universal tool, right? You can use, I don't know, things, Google Keep, whatever.
Sumerian technology. You can stick it on clay tablets. It will work just as well.
Great. Then I just have one closing question and little surprise for you. So before it, I was talking to Jack Dorsey, and he actually recommended like a hidden Twitter feature. It's a bot that is called Time Machine, the Time Machine command. It's very, very simple to use if you're enabled for that. And I was like just scrolling through your old timeline at Twitter back to the time when you were working as a senior engineer in search at Google in the year 2003. And I now add a comment at Twitter Time Machine, and it brings us back to the year 2003, and you have the chance to actually whisper something into your young self's ears back at that time. What would you whisper into your young self's ears?
Hey, the first things that pop to mind have nothing to do with work. If I had to give myself professional advice, like sort of going back to that age, to that time, pay lots of attention to the people who are making decisions and what actually matters to them, because that is what you're going to need to understand in order to actually influence decisions.
Wow, that was a good one.
Don't ask me, I'm just faking it.
Well, it was very spontaneous, so congrats on that one. Yonatan, thanks a lot for your time and for the great advice that you gave. And I can just recommend everyone here, all of my listeners, to check your articles on Medium and your Twitter profile. Maybe you enable it at a certain time again. I hope so.
Hopefully soon. That would be nice. If you want to be nice and terrified, that's always the joy. Get security and privacy engineers in a room and get them talking about horror stories. Well, thank you, Tobias. It's been a wonderful
Let's get that started. Thanks a lot. Enjoy your day. Bye-bye.
Goodbye.
Thank you for listening to the AlphaList podcast. If you liked this episode, share it with friends. I'm sure they love it too. Make sure to subscribe so you can hear deep insights into technical leadership and technology trends as they become available. Also, please tell us if there is a topic you would like to hear more about or a technical leader whose brain you would like us to pick. AlphaList is all about helping CTOs getting access to the insights they need to make the best decisions for their company. Please send us suggestions to cto@alphalist.com. Send me a message on LinkedIn or Twitter. After all, the more knowledge we bring to CTOs, the more growth we see in tech. Or, as we say on AlphaList, accumulated knowledge to accelerate growth. See you in the next episode.